All right, in this lesson, we are going to talk a little bit more about the forms of quadratic equations, but more about deriving equations based on the information we're given. Okay, and so we've talked about standard form, vertex form, and root form, and it's important to know which information you get for free based on which form you have. And so for standard form, you have these A, B, and C values, and the only information you really get for free is the y-intercept, which is just going to be that C value. Okay, so when you don't see any parentheses and you have your A, B, and C, that C value will be your y-intercept. You can also get the axis of symmetry using a formula, x equals negative b or opposite of b over 2a. And then from there, you can plug that in to the original function to get the full vertex. And so the negative b over 2a is just your x coordinate. And then when you plug that in to get the y value, that will be the y coordinate of your vertex. Okay, and so looking at our graph, this C value will be our y-intercept. It's important to know that that is not your vertex. So talking about vertex form, we do get the vertex for free. And so we know the axis of symmetry is x equals h. We have these parentheses and we have a square. That's how you recognize vertex form. And then your vertex will be the opposite of what you see with x for your x coordinate. And then you take this outside value as your y coordinate. Okay, and so our axis of symmetry, and then our vertex, HK. A lot of students confuse K with C, and so just notice the difference. They're not the same value. K is the y coordinate of your vertex. It's usually your max or min, in this case, your minimum. And then the C value is just where it crosses the y-axis. They're not usually the same unless your quadratic has the vertex sitting on the y-axis. Okay, and so no parentheses means you have standard form. If you have a parentheses and x just written one time and a square, that means you have vertex form. And then root form, you'll have two sets of parentheses and you'll see x written twice. And from root form, you get the roots for free. And so the roots are the same thing as x-intercepts, are the same thing as zeros, and they're also called solutions. You'll see that when we start solving quadratic equations, but they're given by R1 and R2. Okay, so looking at our graph, you can identify your roots just by taking the opposite of what's with x. And so you have R1, R2, either order, it doesn't matter the order. Okay, and so depending on what information you're given, that determines which form you start with. So we're going to do some review. And so here we're given standard form. And so we can see that A equals -1. We can see that B equals -8. And we can see that C equals -15. Okay, and we want to find the vertex form. And so in all of these forms, the A value is the same. Okay, the same A value appears in all three equations. And so we already know that A is -1 right off the bat. Okay, and to find h, the x-coordinate of the vertex, we use our formula, -b over 2a. Negative b would be +8, looking at this value. 2 times a would be 2 times -1. So that simplifies to 8 over -2, which is -4. Okay, and so now that we have our a value and our h value, we just need to find the k value. And so we find that by taking our original equation and plugging this x value in for both x's. So write down your rule, -x² minus 8x minus 15. Replace both x's. Some people only replace one and then they get confused because they still have an x hanging around. Both x's should replace with -8 or -4. And make sure you're using these parentheses. They're very important. They'll save you a lot of careless mistakes. Okay, and so -4 squared is +16, but then we still have this negative outside, so that's still going to be there. -8 times -4 is +32, and then -15. Once you have these three numbers, this first number should always be half of the second, and they should be opposite signs. That's a good way to check your work to make sure you have the right axis of symmetry. Okay, and so from there we can keep simplifying to get us +16 minus 15, which is 1. Okay, and so that's our k value. We have everything we need to write our equation. And so our equation for vertex form looks like this, but now we know A is -1, we know H is -4, and we know K is 1. So by the time I simplify this, you're just going to see a negative outside, you're going to see an x plus 4 inside the square, and then you're going to see a +1 outside. That's our final vertex form. Okay, in this next one, it says write a quadratic function for the parabola that passes through this random point and has roots. Okay, so we're given the roots. That tells me I need to start with root form. Okay, and so for root form, it's y equals a x minus one of the roots, x minus the other. And so you can view those minus signs as opposites. So if one of my roots is -6, I'm going to see an x plus 6. My other root is 4, so I'm going to see an x minus 4. And we still don't know what a is. Okay, and so that's what this random point is for. It's giving us an x and a y that we can substitute for x and y in this equation. Okay, and so my x is 2, my y is -3, so I'm going to replace y with -3, and I'm going to replace both x's with this 2. So 2 plus 6, 2 minus 4. Okay, and so that gives me 8 for the first parenthesis, -2 for the second parenthesis. And then from there, 8 times -2 is -16. I'm going to put that in front of the a because it makes it more obvious what you need to do next. And that's divide by the -16. Okay, and so our a value ends up being +3/16 since these negatives cancel. Okay, and so now that we have a and we have our roots, we can write our final root form, which is y equals the a value we just found, x plus 6, x minus 4. Now they didn't specify convert to standard form, and so it just said write a quadratic function. We just wrote a quadratic function. If we want to get real precise, we can use the function notation, f of x instead of the y equals. It's the same thing, and so that would work too. Okay, we're going to skip the applications and go straight to these other examples because they take a lot of work. All right, like I mentioned above and like we just did in the examples, if we are given key features like the roots or the vertex, we can write a quadratic equation in either root form if we're given the roots or vertex form if we're given the vertex. And then if we need standard form, we would just convert it to standard form. If you are not given significant points like roots or vertex, you have to start with standard form. It's not the ideal situation because you need at least 3 points, and they're usually random points because they're not significant or reference points like the roots or the vertex. And then if you have technology like your graphing calculator, you can do what's called a quadratic regression, and your calculator will just tell you what A is, what B is, and what C is. Okay, if you do not have technology, you have to set up a 3x3 system and then solve it. And so that's what we're going to do, is we're going to practice doing it without technology. Okay, and so we're going to do two examples. In this first example, it says write the equation of the parabola with the following 3 points. And so these points are just random points on the graph. They're not the roots, they're not the vertex. Okay, and so we have the point -2, 8, we have the point 4, 10, and we have the point 5, 6. You could try to graph these and try to make the graph of these, but that's not usually the best way to do this, especially if the numbers are large and the points aren't really falling anywhere near each other. And so we're going to start with standard form, which is ax squared plus bx plus c. Okay, and in each case, we're given an x and a y for each point. Okay, and so the best way to set it up is to write ax squared plus bx plus c equals, and then you're going to fill in the x and the y. Okay, and we're going to do that for all 3 points. We have ax squared plus bx plus c equals y. Ax squared plus bx plus c equals y. Y. Okay, and so here my x is -2 and my y is -8. So the x's, both x's are -2, and then the y is -8. And so when I simplify this, -2 squared is 4, and so that gives me 4a. -2 times b is -2b equals -8. Oh, plus c. We have that plus c in every equation. Okay, so for my next point, x is 4, y is 10. So replace the x's with 4, replace the y with 10, and then we simplify and get 16a plus 4b plus c equals 10. And then for the last point, we're given an x and a y. X is 5. Y is 6. So that gives me 25a plus 5b plus c equals 6. Okay, and so this gives us our 3x3 system. Okay, the red equation, 4a minus 2b plus c equals -8 is equation 1. Equation 2 is the green equation, which is 16a plus 4b plus c equals 10. And then the blue equation will be our equation 3. So 25a plus 5b plus c equals 6. Okay, and so now before you solve this 3x3 system, it's going to be a nice, easy 3x3 system because you should have a plus c from every equation. There's no x with this c, and so every equation has a plus c, so that's going to be the variable we want to eliminate. The other thing you want to check is make sure your a term, the coefficient on a, is positive because this comes from x squared. And so because it's coming from x squared, you should not get a negative number there. And if you did, you made a calculation error. When you square a negative, it should be positive. So the coefficient of a should always be positive. I see that mistake a lot. Okay, and so now, since we have every equation has a c, pick one of your equations. I usually pick the one with the smallest numbers and make it negative. So I'm going to pick equation 1, and I'm going to multiply it by a negative. So flipping everybody's sign, I now have -4a plus 2b minus c equals 8. Do that twice. We're going to do negative equation 1, which is -4a plus 2b minus c equals 8. Just imagine distributing a negative to every single one of those. Okay, and the reason why I did that is because now I have a negative c. All I have to do is copy the other equations. And so equation 2 is 16a plus 4b plus c equals 10. Equation 3 is 25a plus 5b plus c equals 6. Okay, and in both situations, the c's are going to cancel. Okay, and so in my first setup, I get 12a plus 6b, c's cancel, equals 18. All of those are divisible by 6, and so I'm going to go ahead and simplify. 2a plus b equals 3. Okay, and so that's going to be my equation 4. And to get equation 5, I have 21a plus 7b equals 14. Those are all divisible by 7, so I'm going to go ahead and simplify that one as well. 3a plus b equals 2, and that will be my equation 5. Okay, and so equation 4 and 5 join together, and then we can use elimination easily to solve for the b's. And so if I make equation 5 negative, I would have negative 3a minus b minus 2, and then the b's will cancel. That's why I made it negative. Okay, and so I get negative 1a, b's cancel, equals 1, and so a equals negative 1. Okay, from there I can use equation 4, 2a plus b equals 3, which means 3 plus b equals 3, or 2 plus b equals 3. And then subtract 2 from both sides, and we get b equals 1. Okay, so now that we have a and b, we can go up to any of these original equations. I'm just going to choose equation 1, 4a minus 2b plus c equals negative 8. We now know a is 1. We know b is 1. Or a was negative 1. Sorry about that. A is negative 1. 1 divided by negative 1 is negative 1. Okay, and so up here I get negative 4 minus 2 plus c equals negative 8. That gives me negative 6 plus c equals negative 8. Add 6 to both sides, and we get c equals negative 2. Okay, so now that we have a, b, and c, we can write our equation. We know a is negative 1, we know b is 1, and we know c is negative 2. So in its simplified form, we would have y equals negative x squared, and then b is 1, so plus x minus 2. We don't write the 1s. Okay, and so from there we can find the axis of symmetry, because that's our negative b over 2a. We know b is 1, and we know a is negative 1. And so the x, or axis of symmetry, is negative 1 over negative 2, which simplifies to 1 over 2. So x equals 1/2. And then our y-intercept is just our c value, and so 0, negative 2. Okay, we're going to do one more example, and in this one, we're actually given the c value, because that's the y-intercept. When you see 0 as the x-coordinate, that's going to tell you your c value. Okay, and so you'll see that when we start plugging them in. Okay, and so once again, we're given 3 points, 0, -3, -1, -2, and then 1, -2. These aren't necessarily the vertex, they're not the roots, we're just told we have 3 points. Okay, and so for our setup, we know we have to start with standard form, ax squared plus bx plus c. And so ax squared plus bx plus c equals y. Ax squared plus bx plus c equals y. Ax squared plus bx plus c equals y. And so for this first point, x is 0, y is -3. And when we simplify, we get 0 plus 0 plus c equals -3, which we could have written right off the bat, but now you're seeing what it would look like if you substituted the x and y. In this next point, I have x and y, which is x is -1, and y is -2. -1 squared is just 1, so a, -1 times b is -b. And then plus c equals -2. And then for the last point, x is 1, y is -2. And so 1 squared is 1, so just a. 1 times b is just b equals plus c equals -2. Don't forget your plus c. Right? And so when I write my system, equation 1 is very simple. C equals -3. Equation 2 is a minus b plus c equals -2. In equation 3, a plus b plus c equals -2. Okay, and so because c is -3, we can go ahead and substitute that for our c's, and that will give us a 2x2 system right off the bat. Okay, and so if you don't have this setup, you need to use elimination. If you do have this setup, use substitution. Substitute your c value. Okay, and so my green equation, a minus b, and then c is -3 equals -2. We'll just move the constant to the other side. And so this -3 came from the fact that c was -3. Okay, and so a minus b equals 5, or just kidding, it's 1. -2 plus 3 is 1. Okay, and so that came from substituting equation 2, and that gives us our equation 4. Equation 3, we have a plus b, and we know c is -3. So now when I add 3 to both sides, one of those should have been positive. Nope, they're both -2. Plus 3, we get a plus b equals 1, and that will be our equation 5. Okay, and so my 2x2 system from equations 4 and 5 is a minus b equals 1, and then we have a plus b equals 1 from this equation. The b's will already cancel. A plus a is 2a equals 2, and so a equals 1. And then using this bottom equation, we know a is 1 plus b equals 1. That means b equals 0. And so we have a, we have b, and we have c. We had that from the very beginning. Okay, and so we knew the y-intercept right off the bat was 0, -3. We can find the axis of symmetry using -b over 2a. b is 0. 2 times a is 2, so we get 0 over 2, which is 0. Okay, and then our equation, since A is 1, B is 0, and C is -3, we're going to have y equals x squared. Don't write the 1. And then 0x we're not going to write. And then C is -3. So x squared minus 3. And so if you picture that on the graph, it's just the parent function moved down 3. And so it makes sense that our C value is also our, right where the axis of symmetry is, because it's also the vertex. And then you can also imagine the symmetrical points on each side, the -1, -2, and the 1, -2. And so these points were pretty easy to graph and pretty easy to make it where you could check your work.